All right, this is the What's That Smell Lab. Essentially, this is kind of the culmination of all we've done this semester. We've looked at a pretty complicated molecule in the reductive amination and assigned all of its signals that we could. We have, with a mystery reaction, made an unknown. With known starting materials, we knew what we had, we knew the mass of the product, and we were able to figure out what we've made. This time, we're switching things up a little bit. We don't know what we actually are starting with, and we don't know exactly what we're ending with either. What we do know is that they are two smells that are assigned to us. We have banana 2A, banana 2B. If you guys were here in person, you would grab the bottles themselves, and they say how much to add, 4.8 grams. They say the molecular weight. So that could potentially help you a little bit in figuring out what the heck they are. This one has a density on it. But essentially, we're putting those two things together. We are refluxing them. We're adding a little bit of sulfuric acid. It's catalytic. Maybe that gives you a hint. And we're making some product. So we're doing that reflux for a while. It's a 45-minute reflux. Usually this is a fun one to stand around and chat for a little while. Then we're just doing an extraction followed by a distillation. So kind of all things that you guys have done before. And then we're just following that up by getting your proton NMR and your carbon NMR and your IR data to figure out what you've made. So we're going to walk you through the experiment, but I think that that's kind of all the introduction that we need. Do you have anything to add?
Yeah, the only thing is we call the experiment What That Smell because the products that you're making in this experiment has some characteristic smell. So while banana A and banana B do not smell like banana, the product of this reaction smells like banana.
And all of you have kind of done Organic Chemistry 1 lab, and if you think back to the hexyl acetate preparation, I remember doing that, and it kind of has a fruity smell, and all of these are smells that could be added as artificial flavors to different products. So, yeah. So, all right, cool. We'll get going. All right, here's our reflux apparatus. We have our 6.2 milliliters of banana 2A. We have our 4.8 grams of banana 2B. And we added our 5 drops of sulfuric acid. You can see we have quite a nice reflux going on. And
got some porous carbon boiling chips in there.
And we are essentially waiting for 45 minutes for this reaction to go to completion. We've now refluxed for the given amount of time, and we need to allow the reaction to cool to room temperature prior to doing our extraction. So we're going to turn this off. Heat is off now, and we're going to remove the heat by pulling out these heating blocks because we have the reaction supported at that correct location, the neck of the flask. We can just pull that out, and now it'll start to cool down. So now we're going to give it a little while to cool to room temperature, and we will continue with the extraction. Now getting ready for the extraction, I'm going to put the 50 milliliters of water into our separatory funnel, which the reaction will then be added to that. So getting our extraction ready. The reaction now has been adequately cooled. I can hold it with my hand, no problem there. So we're now going to add this to the separatory funnel. The reaction is on this cork ring. I'm going to grab the reaction and I'm going to decant it into this separatory funnel. It already has water in it. Just slowly adding it in there. Now we're going to add 25 milliliters of methyl tert-butyl ether to the separatory funnel for our extraction. After shaking the water organic solvent mixture, we now have a separatory funnel that has clearly 2 layers. We can see the interface right there. And we are going to separate the organic from the aqueous layers. We have shaken the separatory funnel, vented, and allowed the layers to separate. We removed the aqueous layer and put it into a beaker. Now we've put the organic layer back into that sep funnel, and we are adding water, another 25 milliliters of water. We're going to go through that extraction protocol again, followed by 25 milliliters of our saturated sodium bicarbonate solution. And then we are going to get rid of the aqueous. So that's what we're doing right now. All right, we now have our combined organic layer that we obtained from our extraction sequence, but it might have a little bit of water still mixed with that organic. So the next thing we're doing is drying with sodium sulfate. Sodium sulfate forms a complex with water. It becomes a hydrate, and that pulls the water out of that organic solution. So that's what we're going to do next. We have now transferred our organic solution from here to the round bottom flask, and now we are going to remove the solvent to leave behind our material. So that's the next step.
Decanted?
No.
All right, so we decanted the organic layer off the drying salts into a round bottom flask. We set up a simple distillation apparatus here. We've got our pre-weighed vial for getting the mass of our final product, and then 15.621. And what we need to be aware of here is, we got a lot of MTBE in there, so we're going to be expecting material to come off at about 55 degrees. I've got a collection beaker here for that. And then once the temperature gets above about 110 degrees or so, then we got to start paying attention. Because our product is unknown to us, we don't know exactly what temperature we're shooting for here. But it'll rise up, it'll settle at another temperature, and that's when we'll switch over to collecting into our little vial. To get our all right, so we got our final product here. You can see the mass of the product in the vial, 119.590 grams. Take it out of the balancer and give you a little closer look at it. See, I got a nice amount of clear liquid there. Smells like banana runts if you've ever smelled those before. And so now we've got to go down and get an IR spectrum of this, a proton NMR spectrum of this, and then the carbon-13 and the depth spectra of this. And we'll share those with you once we get them. The boiling point range that we collected here was 140.8 to 142.3. More soon. Okay, we've got our NMR spectrum here, our proton NMR spectrum. Just wanted to talk to you a little bit about it, see what we found there. First of all, we've got 5 good signals for your product molecule. Those are the ones that have the integration values across the bottom and the peak values across the top. Keep in mind, some of the multiplets there have small outside peaks that may or may not have been peak picks, so don't trust the numbers that are there. In addition to your product, we do see evidence of a little bit of impurity. And so here we've got a small triplet. This is from unreacted starting material. So this triplet in the starting material becomes that triplet in the product molecule. So that's a little bit of evidence of an unreacted starting material. What you have to bear in mind there is if this signal is here for that unreacted starting material, there are other signals for that in the spectrum as well that might be not as clearly resolved from the signals of the product. We also have a singlet here and another singlet down here. Those are evidence of methyl tert butyl ether. So in those cases there, a little bit of unreacted starting material and the MTBE made it through the extraction, through the distillation, and into our product vial. So we'll give you better images of the spectrum on the Canvas site.
All right, well that concludes everything we needed to do for What's That Smell. You guys have everything you need to fill out your procedure and your observations and the spectral data. You will be, the mass spectrum, the IR, proton, and carbon NMR all will be posted on Canvas, so you can use that to fill out your data tables and to discuss that in the discussion conclusions.
Yeah, and I think that's the end of the semester, not the way we envision it happening, but sometimes you just got to make lemonade out of lemons. And what's nice about 237 is you get to the point of the semester that we're at, and the act of conducting the experiments, there's not a whole lot new there. You've measured out solids and liquids before, you've done extractions and distillations. The value is really in the interpretation of the data. And so hopefully the video experience that we provided to you with all the talent that we have was enough to get you to where the learning really takes place, which is the data analysis.
All right, well, we will hear from you about those labs, and we'll talk to you later.